Hello everybody and welcome to Higher Maths in lockdown. We are starting with the straight line, and the first thing to do in the straight line is calculating the distance between 2 points. This is quite an easy start into higher maths, so don't you worry. We'll talk you through it nice and slowly. I'm sure there's some things here you'll remember from National 5, and hopefully it's a good start to your higher maths course. Okay, so I want to calculate the distance between the points 1, 3 and 5, 6. So the first thing I've done is I've drawn them on the bit of paper. I've not bothered with an axis. We don't really need to see that. I just want to look at the points down written in front of me. So at this level of maths, we actually only have a couple of ways of calculating the length of a line. Does anybody know what they are? Anybody? No? Okay, well, using our rulers out, we're not allowed to do that at this level. So that leaves two ways of doing it. Maybe if I do this, it might help you along a little bit. Anyone? Yeah, that's right. Trigonometry Sohcahtoa is one way of finding the length of a side of a triangle, but we don't know any angles. How we're going to do this today is we're going to use our good old friend Pythagoras. So, first things first, with Pythagoras, if I'm finding the longest side, the hypotenuse, I need to know the length of the other two sides. So how are we going to do that? That's correct. We're going to look at the coordinates. So the x-coordinate, this point here is 1 along, this point here is 5 along. What is the difference between those two numbers? How far along are we going to go from 1 to 5? And the answer is, of course, 4. Well done everybody who got that. Then we're looking at the y-coordinate, which is 3 and 6. What do we have to do to get from 3 up to 6? That is correct. We have to go up another 3. So now we have a simple Pythagoras problem where we know both sides of the triangle and we're going to try and work out the third side. Pythagoras, remember? Let's call that x. I'm going to square the two numbers and add them together because I'm finding the longest side of the triangle, and then I would want to square root that. 3 squared is 9, 4 squared is 16, add them together I get 25, and then I square root that, and the square root of 25, as you know, is 5. 3, 4, 5. A Pythagorean triple. We'll get to that in a minute. Okay, so the distance between those 2 points is 5. How we're going to solve this every single time is by using Pythagoras. We need to use the points to work out the two sides of the triangle, the along and the up, and then we use Pythagoras to work out the x squared. Now, because we're always finding the diagonal here, we're always finding the hypotenuse, we will always do Pythagoras where we're adding. Okay, right, let's look at a slightly harder example. In terms of more difficult, we're just going to introduce some negative numbers and see how that makes it any more harder. So, same as before, got an imaginary axis here, -4, -3 would be somewhere around here. -8, -5 would be somewhere down here. Draw them together, put my points in, get my triangle. Now, we're going to work out how far along it is, and to work out how far along it is, we'll look at the x-coordinates, the first numbers. So we're at -8, and then we're at -4. So what is the difference between those two numbers? The answer would be 4. The vertical, up and down, -5, -3. The gap between those two numbers is 2. So we've got a Pythagoras situation happening where 4 and 2 are the two sides that we're going to use. So same as before, I'm going to call that an x. I'm going to square my numbers. I'm going to add them together. 4 squared is 16, 2 squared is 4. Add that together, we get 20. And then I'm going to square root 20. Here's a little bit of revision from last year, National 5. We have a surd and we're going to simplify the surd. So how do we do that again? We didn't need it for the last example because it worked out to be 5, it worked out to be a nice number. If I want to simplify root 20, I need two numbers that times to make 20. One of them has to be square rootable. And that would be 4 times 5. And the square root of 4, I know, is 2. So my final answer is 2 root 5. Okay, so you need to know how to do surds. You need to remember how we do that from last year. So just in case you need a little bit of revision on that. With surds, for example, if I wanted to simplify root 32, I'm looking for two things that multiply to make 32. One of them has to be, I'm going to call it square rootable, that's probably not even a word. Here is the list of square numbers. So I want two things that times to make 32. One of them basically has to be on that list. Now, this is a slightly different one because we've actually got two options here. In terms of root 32, that could be 4 times 8, or it could be 16 times 2. If you get that situation where there's two options, we always want to go with the one that's the biggest. So over here, I'm going to go this way. Square root of 16 is 4, so that is 4 root 2. Root 32 is 4 root 2. So hopefully you remember how you do your surds from National 5. The other thing I mentioned a little minute ago was triples, Pythagorean triples. We have some situations with numbers that work out perfectly. 3, 4, 5 is a very famous Pythagorean triple. Another one, 6, 8, 10. Another one, 5, 12, 13. At this level of math, it just helps if you know some of your Pythagorean triples. It makes it a little bit faster. Okay, so back to the lesson. You're finding the distance between 2 points. To do that, we're going to draw the line. We're then going to create a right angled triangle. You're going to look at the gap in the x values to get how far along it goes. You're going to have a look at the gap in the y values to work out how far up it goes. And then you're going to do Pythagoras to get to an answer. You will notice I have not talked about a formula for this. There is something called the distance formula. The distance formula looks quite confusing. This is it. That there is your distance formula. It's exactly what we have done. We looked at the difference in the x coordinates, 5 take away 1, and then we square it. We look at the difference in the y coordinates, 6 take away 3, and then we square it. And then we square root everything because we're doing Pythagoras. You don't need to know the distance formula. You don't need to remember the formula. You just need to know that we're using Pythagoras to calculate the distance between 2 points. Okay, you should now be ready to try some yourself. So here we are. We have 6 questions. All you need to do is pause the video and then work through your 6 questions. Okay, so pause it now, work through your 6 questions, and then you can come back in a little second and we'll have a look at the answers. Okay, well done class. Hopefully you're looking at 6 out of 6 here. Let's work through it. So we're going to get the difference between the x coordinates, which should be 7. The difference in the y coordinates, which is 4. So I'm going to do 7 squared add 4 squared. which is 49 add 16, and that's going to tell me that it's 65. And I just want to double check if I can simplify that or not. So I'm looking at my list of square numbers. I need two things at times to make 65. One of them has to be on that list, and there isn't. So my final answer for this is just going to be root 65. We don't need to change it to a decimal at this level of maths. We are absolutely delighted to use SUDS. Number 2, difference between the x coordinates. Minus 2 all the way up to 5 is a gap of 7. The difference between the y coordinates is 1. Now, you might be wondering, wait a minute, is this minus 1 or is it positive 1? It doesn't matter. It doesn't matter because you're going to square the answer, and when you square a negative you get a positive anyway. So don't worry too much about is it a negative or a positive. I would always just go with the positive difference between them. That's going to give me 49 add 1, which is going to give me 50. Oh, little mistake there. And then I'm going to square root 50. So two numbers at times to make 50. One of them has to be square rootable. That's root 25 times root 2, which is going to give me a final answer of 5 root 2. Number 3. The gap between the x coordinates, minus 4 all the way up to 7, is going to give me a gap of 11. Minus 1 going up to 2 is going to give me a gap of 3. I'm going to square both those numbers. 11 squared is 121. Hope you didn't have to use a calculator to check that. Add on 9, that's going to give me 130. And then I'm going to square root 130. And I'm just going to leave it like that. Number 4, minus 3 going down to minus 10 is a gap of 7. Minus 2 going down to minus 7 is a gap of 5. 7 squared is 49, 5 squared is 25. Add them together, 74. Square root 74. And again, I'm just going to leave it like that. Last two questions, number 5 and number 6. So number 5, the gap between the x coordinates, minus 8 going all the way up to 3, that's a gap of 11. The gap in the y coordinates, minus 4 going to minus 2, that's a gap of just 2. Square my numbers, add them together, square root 125. I know that 25 times 5 makes 125, and that would give me 5 root 5. Remember, at this level we are assuming that you know your stuff from National 5. So we are assuming that you can do SUDS. I'll give you a little recap just in case you'd forgotten how to do SUDS. It's important we have those key skills from National 5. Last question. 5 going all the way to minus 2, that's a gap of 7. Got loads of 7s in this exercise. 7 going to 3, that's a gap of 4. Square my numbers. 49 add 16, which gives me 65, which will give me the square root of 65. And that there is the first lesson in higher maths. It's calculating the distance between 2 points. If you got 6 out of 6, you can give yourself a little virtual elbow pump. And I'll be back soon with the second lesson in higher maths. If you like this video, give it a thumbs up, share it with your friends, leave a comment below.